Azure Monitor alerts provide proactive notifications and actions based on metrics, logs, or platform events. Building on prior knowledge of interpreting metrics and configuring logs, alerts serve as an essential mechanism to maintain cloud resource health. They help administrators respond to potential capacity limitations, performance bottlenecks, and security threats in real time. By leveraging a systematic alerting strategy, teams can detect anomalies earlier and initiate remediation steps swiftly. Azure Monitor supports several types of alerts, including metric, activity log, and application insights alerts. Understanding these builds a foundation for implementing robust solutions that minimize downtime and enhance operational efficiency. Alert rules define the conditions under which Azure Monitor triggers an alert. Administrators typically choose metric-based rules to monitor resource metrics, such as CPU usage or memory. Alternatively, activity log alert rules rely on specific events in Azure, such as resource creation or policy changes. Defining thresholds for metrics or specifying event criteria ensures alerts target relevant scenarios. Configuring alert rules involves selecting a signal, deciding on severity, and assigning response patterns. By customizing rules, administrators can balance sensitivity and noise, ensuring the system highlights only critical incidents that require immediate investigation. Metric alerts rely on quantitative data, such as CPU percentage or disk throughput, to establish triggers. By setting thresholds that indicate unusual resource usage, teams can spot performance anomalies quickly. For instance, a metric alert can notify operators when the CPU utilization of an Azure VM exceeds 80% for 5 consecutive minutes. Additionally, grouping conditions, such as aggregations and time windows, enable refined alert generation. This approach reduces false positives and ensures that fleeting spikes do not create unnecessary disruptions. The main benefit is a focused, data-driven approach that promptly highlights situations needing attention. Activity log alerts leverage the Azure Activity Log, which captures management operations within a subscription. This type of alert allows teams to track administrative or operational events across services. For example, an activity log alert can be configured to fire when a critical resource is deleted or a policy is updated. Administrators define conditions based on the event category, resource group, or operation status. Once an event matches those filters, Azure Monitor triggers the alert. This proactive approach streamlines compliance and governance by ensuring crucial changes are monitored, improving responsiveness to errors or unauthorized modifications. Action groups define the notification and remediation actions that occur when an alert fires. Each action group can include email recipients, SMS settings, push notifications, voice calls, or webhooks. By creating multiple action groups, administrators can tailor response pathways for different scenarios. For instance, a high-severity performance alert might trigger multiple notifications and integrate with IT service management tools, whereas a lower priority event might only require an email. Additionally, including Azure Functions or Logic apps within action groups facilitates automated workflows, such as restarting services or creating tickets. This flexibility ensures targeted and timely responses throughout the organization. Configuring an action group typically involves assigning a short, descriptive name and specifying notification options. Administrators then choose contact mechanisms, such as email addresses or phone numbers, and decide how recipients should be notified. Different roles or teams might receive distinct notifications. Demonstrating best practice, organizations often include runtime automation, like a webhook integration with a DevOps solution, enabling immediate remediation. Several advanced options let users customize communication preferences or utilize authentication tokens for secure transmissions. By aligning the action group configuration with the organization's incident response process, administrators ensure alerts become meaningful, actionable signals rather than noise. Alert processing rules help refine and streamline how alerts behave once triggered. These rules allow for further actions like suppressing or modifying alerts under specific circumstances. For instance, administrators might suppress certain alerts during maintenance windows or route alerts to specialized teams outside business hours. Alert processing rules can also adjust the severity of incoming alerts based on advanced logic, ensuring the correct prioritization. By incorporating these rules into their monitoring strategy, organizations can avoid alert fatigue, optimize response workflows, and ensure each alert receives proper handling. This layered approach increases the clarity and impact of crucial notifications. When creating alert processing rules, administrators typically define a scope, such as a subscription or resource group, and specify conditions. These conditions might involve time ranges, tags, severity levels, or alert types. Based on these filters, rules can either suppress, escalate, or route alerts to unique action groups. For instance, one rule could redirect after-hours alerts to an on-call rotation. Another might temporarily silence alerts from a testing environment. These rules run sequentially, meaning administrators can layer multiple rules for granular control. By carefully configuring them, it becomes possible to achieve meaningful alert flows that recognize context and operational needs. Several scenarios demonstrate the value of robust alert configurations. A mission-critical web application might trigger a metric alert at 70% CPU usage, routing notifications to multiple teams. An activity log alert might detect when changes to network security rules occur, alerting a security role through SMS and email. By layering an alert processing rule, such notifications might be suppressed during scheduled patching periods to reduce noise. Meanwhile, organizations can employ advanced logic with an action group that triggers a serverless function to auto-scale resources or revert configurations. These examples underline how alert rules, action groups, and alert processing rules intertwine to maintain operational stability. A successful alert strategy involves balancing proactive and reactive measures. Teams should identify key metrics tied to performance, availability, and security, then define alert thresholds that correlate with potential issues. Employing actionable naming conventions and consistent severity assignments helps unify alerts across teams. Customizing action groups ensures the right stakeholders receive timely notifications, while automated responses can handle predictable incidents. Alert processing rules, however, help reduce alert fatigue by filtering or routing less critical signals. Ultimately, continual refinement, based on practical experiences, keeps alerts relevant and effective. This integrated approach supports efficient, resilient operations in Azure environments without overwhelming technical staff.